This video covers the concept of level of measurement. So level of measurement. And there are 4 levels of measurement that we're going to talk about. The first one is interval, the second one is ordinal, the third one is categorical, and the last one is binary. So we're going to cover this by talking about 2 different examples. The first one is, imagine that our unit of analysis that we want to describe is individual people. And so the variables that we want to gather about individual people are age, maybe their opinions on something on a Likert scale, the nation of origin that each person is from, and whether or not that individual is retired. On the countryside, for that example, we're going to talk about 4 variables. The top one is population, so how many people are there in the country. Second, development status. So typically there are 3 levels of that we talk about. There's a first world nation, a developing nation, and a third world nation. And then the next variable that we're interested in is the language or languages spoken in the country. And then finally, whether or not that country is a member of the United Nations. So I have these variables listed in sort of a logical order according to level of measurement. Now, what do we mean by that? When we talk about level of measurement, what we're talking about is the characteristics of the data itself. And there are some specific characteristics we're looking for. And these are sort of hierarchically ordered. So the highest level of measurement, the one that's the most flexible, that we can do the most with, is going to be your interval level of measurement. So to be an interval variable, you need to have a couple things. First of all, you have to have more than one possible option. And those possible options need to be ordered in some meaningful way. And finally, and this is its really distinguishing characteristic, each unit or level in the variable needs to have a specific meaning. So the best way to tell that is a variable that has units, where you're counting something, whether that's dollars, or you might be counting years. Here with population, you might be counting people. But you have to be counting something. So if you have a 1 versus a 2, when it's an interval variable, the meaning of that number is associated with standardized units. And those standardized units are what you're counting. So another example would be percentage points. So interval variables are very flexible. We can run a lot of different kinds of statistics on them. And the other great thing about them is that you can convert them to the other kinds of levels of measurement. And that's why we have kind of this hierarchical order. You can always go from the top level down into other levels of measurement, but typically you can't go up the other way. So we'll talk about that more in just a minute. So the second level of measurement is ordinal data. So just like interval data, ordinal data has more than one possible category. You have to have more than one possible category or it's not a variable at all, right? And all the things we're talking about are variables. So all of them have to have at least 2 categories, ideally more than that. But to be an ordinal variable, you need to have at least 2 categories. Really, it's better if you have 3 or more. And they need to be ordered in some sort of meaningful fashion, meaning a lower value is always going to be lower than the higher values, and they always are going to show up in that order, and that's a universally recognized order. So you and I would automatically agree on the logic of the order of those variables. So the examples I have here are development status and opinion as measured on a scale. So development status is a pretty commonly recognized measure, and it's well defined. So we know what makes something a level 1, and a level 1 is always going to be have fewer of the characteristics than a level 2. Then a level 2 will have fewer characteristics than a level 3. So they're always ordered. And then with opinions, on the individual side, it's the same sort of thing. So if we use a standard 5-point Likert scale from strongly disagree to strongly agree, you know that strongly agree is always further on one side of the scale than agree, and that's further than neither agree nor disagree, which is further on that side of the scale than disagree or strongly disagree. So there has to be an order for an ordinal variable. The difference between an ordinal variable and an interval variable is that ordinal variables don't have to have standardized units. So the difference between your agree and your strongly agree might be different from the difference between my agree and my strongly agree. These are not standardized scales, right? We're not going to universally agree on what the specific units of those things are, but the order is maintained. So if I say strongly agree, that means for me, even though the units aren't the same, that I agree more than I did if I said agree. And that would be true for you as well. So there's a standard order, just not standard units. The units distinguish an interval variable from an ordinal variable. So the third option here is categorical variables. So these are variables where you have multiple different options, usually again, 3 or more options. And the issue here is that they can't be ordered. So the examples that I have here for the individual: nation of origin. We're not going to order these things, like Canada isn't more than the US, Mexico isn't more than Canada. They're just different. They're the same kind of thing, they're the same category of thing, but you cannot order those categories. So that's an example from if we're describing like individuals. And then on the country side, if you were trying to identify what languages are spoken in a country, a country that speaks Spanish versus Portuguese isn't going to be higher or lower on the scale. They're just two different things. They're comparable because they're languages, but there isn't a universal order that we would all recognize as different. So that is a categorical variable. It has categories, but not orders. An ordinal variable has categories that can be ordered, and an interval variable has measurements that can be ordered and have standardized units of measure. Now, the last level of measurement that we're going to talk about is binary. So binary variables have exactly 2 options. Never a third option. If there's a third option, it's not a binary variable. So these are either on or off, yes or no, and typically they're coded as 0 for no and 1 for yes. That's the most flexible way that we can use the values in the statistics that we run. So a binary variable, again, has exactly 2 options, no more than 2 options, and that makes ordering sort of moot. And clearly you don't have units associated when they're just 2 categories because they're categorical. So the examples I have for that on the individual side are you retired or not, right? Yes or no. You're either retired or you're not retired. And then on the country side, an example of a binary variable is, are you a member of the United Nations? As a country, are you a member? So again, binary variables. Now, I want to offer some cautions though, because even though these seem like really clear categories, there are some caveats. So I've used age as an example of as an interval variable, but this really actually depends on how it's measured. So if we measure age in terms of like what year were you born or how many years have you been alive, then we will indeed be counting in units, and those units are years. Same thing for population. We can count in number of people or number of households within the country. And if we actually look at or measure, like with a census, how many people or households there are in the country, that can give us a population number that is ordered and has a standardized unit of measure. But in both of these cases, we can also measure this in other ways. So for example, we could ask, are you within the age category 0 to 18? Are you 19 to 35? Are you 36 to 65? Or are you 65 plus, right? So we could ask this in a way where we're not actually saying how many years have you been alive, but rather which of these categories are you in? And when we measure this, really we're looking at 4 different categories, and they're ordered categories, but they no longer have that unit of measure, right? So if I indicate that I am in this second group, 19 to 35, which I'm not, maybe I should just indicate the group I'm actually in. So if I indicate that I'm in this group from 36 to 65, then I'm not actually telling you how old I am. I'm not giving you a number of years. I'm giving you a category. So this is no longer interval measurement. This is now ordinal measurement. Why is it ordinal? It's ordinal because people in category 1 are always going to be younger than people in category 2. And people in that category are always going to be younger than the people in category 3. And those folks will always be younger than the people in the final category. So this is ordered, but we no longer have specific units of measure. And the other way I can demonstrate this is by looking at these middle two groups. So imagine that I have 4 people, and one of my people, I'm just going to indicate my people with stars. One of my people is 19 years old, and another one is 35 years old, another one is 36, and another one is 65. So I have a 19-year-old, 35-year-old, 36-year-old, and a 65-year-old. Well, I have 2 people in category 2, this 19 to 35 category, and I have 2 people in my 36 to 65 category. But does that mean that they are the same distance apart from one another? No, it doesn't. For example, my 35 and 36-year-old are 1 year apart from one another. And my 19-year-old and 65-year-old are much further apart. So these are not standardized units. In fact, the difference between category 2 and category 3 can range anywhere from 1 year to decades. So this is ordinal data. This is not interval data, even though we could have measured it in an interval way. Another example of that, and we'll actually just stick with age for a minute because, like I said, you can always go from a higher level of measurement down to a lower level of measurement. So let's imagine that we asked, are you over 18 years old? And that's how we gathered age information for our individuals. This is no longer even ordinal information because there are exactly 2 options. People are either over 18 or they're not over 18. So this is now binary, right? There are only 2 options, and that makes it different from ordinal, where you really want 3 or more levels. And it's different from interval, where you also have to have standardized units of measure. So if I ask the age question this way, this is a binary variable. This is no longer interval. So even though it sort of made sense before to talk about, oh, age is interval because it has a standard unit of measure, it really depends on how you measure it. So you always have to look at the actual data that you have. The other thing that I want to just caution you about is the difference between some kinds of ordinal variables and categorical. So let's say that we're focused here on our opinion variable. And maybe we ask someone, do you love statistics? Let's rephrase. I love statistics is the statement, and people have to indicate their level of agreement with that statement. So from strongly disagree to strongly agree, they have to indicate their opinion of statistics. So I love statistics, and we're agreeing or disagreeing with that. Well, typically you have a set of scale points and they're nicely ordered, but sometimes you have additional categories like I don't know, or not applicable, or prefer not to answer, right? So even though I might have a scale from strongly disagree to strongly agree, if I have these additional options, so not applicable, or don't know, or prefer not to answer, these now can't be ordered with the rest of our variable. We can't stick a not applicable or a don't know really in any of these categories because it's a completely separate thing and it can't be ordered with these. So if you have any of these additional options, this kicks us down from an ordinal level to a categorical level. unless we remove all the observations that have these extra answers, or if we make a choice about where to put them. For example, if they don't know or prefer not to answer, we could imagine that we're going to enter that as neutral. But that is a highly problematic choice to make, because maybe someone prefers not to answer because they're so extreme on one side or the other. So sticking them in neutral might really be lying in their behalf. So we need to honor the fact that folks are saying this isn't applicable to me, so I'm not even on the scale. I don't know, so I don't know really which answer to provide, or I prefer not to answer. I have an opinion, but I'm not going to share that with you. If we leave those in the data set, the problem is we might set values to each of these, right? Because it's ordinal, so we might say like strongly disagree is a 1, disagree is a 2, neutral is a 3, agree is a 4, strongly agree is a 5. If I now add 6, 7, and 8 for our additional values over here, what it looks like in the math is that not applicable agrees even more strongly than strongly agree, and that don't know is even stronger agreement than that, and prefer not to answer is an extreme level of agreement that's even further this way on the scale. Obviously that doesn't make sense. So we need to recognize that when we have these kinds of answers, even in something that would otherwise be ordinal, it's actually categorical data. So again, you can always go from a higher level down. So if I gathered age information and I asked you how many years old you actually are, I can always then later stick it into bins or give you a binary variable for if you're over 18 or not. I can assign that. But if all I have done is ask you, are you over 18? I can't then infer what your actual age is. So we can go down in levels of measurement, but not up. And again, those levels of measurement are interval, ordinal, categorical, and binary. There you go.